Hey everyone, and welcome back to the channel. Today, we are diving into the world of clutch coupling assemblies. I'll be breaking down the different types you'll commonly encounter, covering everything from the basics of how they work to the specific applications of each. We'll look at least three main types, and I'll show you the key differences between them so you can easily identify which is right for your needs. Let's get started. Hey everyone, let's dive into the fascinating world of vehicle clutches. We are going to break down the purpose and design, exploring the different types of clutch coupling assemblies. First, let's look at the stages of work a clutch goes through. Stage O&E is the engagement phase. This is where the clutch smoothly connects the engine to the transmission, transferring power. Think of it like gently easing your foot off the clutch pedal in your car. It's a gradual process, preventing sudden jolts and ensuring a smooth transition. We need to consider the materials used in the clutch plates, the pressure plate design, and the overall system's ability to handle torque smoothly. Poor engagement can lead to premature wear and tear, or even damage to the transmission. We'll look at specific examples of how different clutch designs achieve this smooth engagement later. Stage TWO is the power transfer stage. Once engaged, the clutch is responsible for transmitting the engine's power to the transmission and ultimately, the wheels. This is where the clutch durability and strength are crucial. It needs to withstand the constant stress of transferring potentially huge amounts of torque, especially during acceleration or heavy loads. The friction materials, the clamping force of the pressure plate, and the overall design of the clutch assembly all play a vital role in its ability to handle this power transfer effectively. We'll discuss the different materials and their properties in more detail. Stage 3 is the disengagement phase. This is when you depress the clutch pedal, disconnecting the engine from the transmission. This allows you to shift gears without damaging the transmission. This phase requires a precise and controlled release of the pressure on the clutch plates. A poorly designed disengagement system can lead to difficult gear changes, slipping, or even clutch failure. We'll examine the hydraulics and mechanical linkages involved in this process. Now, let's talk about the assignment and device of the clutch itself. The primary function is to connect and disconnect the engine from the transmission, allowing for gear changes. It's a critical component for smooth operation and preventing damage to the drivetrain. We'll explore the various types of clutches, including single-plate, multi-plate, and centrifugal clutches, and discuss their respective advantages and disadvantages. We'll also delve into the materials science behind the friction plates, looking at the different materials used and their impact on performance and longevity. Next up is the clutch release actuator. This is the mechanism that allows you to engage and disengage the clutch. In most vehicles, this is the clutch pedal and its associated hydraulic or cable system. We'll explore the different types of actuators, their operation, and common problems that can arise. We'll also discuss the importance of proper adjustment and maintenance to ensure smooth and reliable operation. Finally, let's look at the clutch mechanism as a whole. This encompasses all the components working together to achieve the clutch function: the pressure plate, the clutch disc, the release bearing, and the actuator. We'll examine how these components interact, the forces involved, and the critical tolerances that ensure proper operation. We'll also discuss common failure points and troubleshooting techniques. Understanding the entire mechanism is key to diagnosing and fixing clutch problems. Hey everyone, and welcome back to the channel. Today, we're diving deep into the world of vehicle clutches, specifically, the different types of clutch coupling assemblies. Let's start by looking at the clutch mechanism itself. Think of it as the crucial link between your engine's power and your transmission. It's responsible for smoothly transferring that power, allowing you to start, stop, and change gears without grinding everything to a halt. We'll be exploring the internal workings, the different components, and how they all work together in perfect harmony, or, when they don't, what goes wrong. We'll cover everything from the pressure plate and the clutch disc to the release bearing and the throwout bearing. We'll even look at the different types of clutch designs, like single-plate, dual-plate, and multi-plate clutches, and discuss their respective advantages and disadvantages. We'll examine the materials used in their construction and how those materials impact performance and longevity. Now, let's talk about some of the major faults you might encounter with your clutch. A slipping clutch is a common problem, often caused by worn-out clutch plates or a malfunctioning pressure plate. This results in a loss of power and a burning smell. Then there's the issue of a clutch that won't disengage properly. This can be caused by a number of things, from a broken release bearing to a hydraulic system problem. We'll cover the symptoms of these issues, how to diagnose them, and what you can do to fix them. We'll also discuss the importance of regular clutch maintenance, including proper adjustment and fluid changes, to prevent these problems from occurring in the first place. We'll even touch upon the potential consequences of ignoring clutch problems, from minor inconveniences to major, expensive repairs. Next up, we'll explore forced control mechanisms. These are the systems that actually operate the clutch, whether it's a hydraulic system, a cable system, or even a pneumatic system. In some heavy-duty applications, we'll examine the components of each system, how they function, and the common problems associated with each. We'll look at bleeding hydraulic systems, adjusting cables, and troubleshooting air leaks in pneumatic systems. We'll also discuss the advantages and disadvantages of each type of control system. Now, let's get our hands dirty. We are going to show you how to remove the clutch discs from a Gazelle car. We'll walk you through the process step by step, highlighting important safety precautions and tips to make the job easier. We'll show you the tools you'll need, the proper techniques for removing the components, and how to avoid damaging any of the parts. This will give you a good visual understanding of the clutch assembly and its components. If you're in Moscow and need to replace your clutch, we'll also provide you with some information on prices and stores where you can find clutch discs and linings. We'll give you a range of price points and some reputable suppliers to help you make an informed decision. And for those of you outside Moscow, don't worry. We'll also provide some resources for finding clutch parts in other regions. We'll discuss online retailers, local auto parts stores, and other avenues for sourcing the parts you need. Finally, let's talk about clutch replacement. We'll show you how to replace a clutch on a VAZ 2109, 2199 without even having to remove the transmission. This is a time-saving technique that can significantly reduce the labor involved in a clutch replacement. We'll show you the steps involved, the tools you'll need, and some helpful tips to make the job go smoothly. We'll emphasize the importance of precision and attention to detail to ensure a successful and long-lasting repair.